Hello, this is Stacy Thomas here for TCS002, and I'm going to be explaining web search engines for advanced database systems. So, a web search engine is a type of program that uses keywords to search for documents that relates to the specific keywords that the user types in. So depending on the results found, it will give that display or that information or the document to the one who requested for it. So here we have examples of Google and Alta Vista. And the importance of search engines. There are over 8 billion web pages available, and it would be very difficult to find that information over that many resources. So the search engine, depending on the keywords that is specifically used, it takes that information and transforms it into a result that the individual can easily access. So instead of that many resources, it sorts it and gives us the more filtered results. So types of search engines are crawler-based, directory, specialty, hybrid, and meta search engines. Crawler-based search engines, these access the web pages to categorize and analyze them and then add them to the search engine's database. So once it obtains a query, it will categorize it and it'll analyze it. Then in the crawler-based search engine, in the database, it includes all these pages to it so that it can constantly be updated and the web page can be drawn again. So that is used for crawler-based examples: Google, Yahoo, and Ask.com. And directories are websites sectioned in specific categories. So Yahoo has a specific directory, and so each category is done by human editors and are placed in the directories database. So it is sectioned into specific categories of specific results. Specialty search engines, they help the user to search in different areas and specific types of lists. So specialized on a specific topic. So AskJeeves, it's a question and answer search engine. MedHunt only provides medical information. So it is specific to a category. On medical, on sports, it is a specific search engine, narrowing down the search process so there won't be that many results, that many web pages to filter from. It'll be on a particular topic. Hybrid search engines, they use both crawler-based search engines and directory. So crawler to analyze the results, and it'll check in the directory for special keywords or special web pages that are being requested. Meta search engines that combine all the results from all the other search engines into one big list. So this includes not just 2 or 3. It'll combine all the results from these search engines into one big list. And then the way to use search engines, as you can see over here, you can use a plus or minus symbol, the plus before each word, and will only give us results that contain web pages that have both the words. And on the other hand, if you use minus, you're looking for a specific topic. Like for example, here we're doing the minus Shakespeare, minus sonnets. So this will only give us that specific information, whereas here, both the words, whatever contains both the words will appear. And you can use quotation marks to find a specific code that was said or used, and that will obtain us results with that particular code. And then one other way we can search is using Boolean operators. This results in and, or, not, or near. This just gives us a better way to search to find the information that is needed. Next, I'll be explaining a full text index. So for this search, why do we use it? So before a full text search, we use metadata searching. So in this, we had to include customer name. In this example, we can see we use customer name, account, document, date, balance. So each one had its own specific category, and it needed to be included like that. So in order to improve this, we use a full text search. So in metadata searching, we had indexes that are extracted from the document, string type search, equal and like. So this is like a comparison. If a certain text equal another text and we wanted to get that information with two texts are similar, we get that, and it's limited to exact matches. And we have an indexing engine, and we can only extract AFP, line, and PDF. So searching using a viewer is like on Word when we use the find. It can be used to find a certain document by searching it. So it'll find what, and then once we type in that information, it'll find a specific text. And then searching from the viewer is exact matches only, because it'll be specific to the words you type. It must retrieve the document before searching, and only practical if users know the text exists. So if we know the text exists within the document, then we can retrieve it. And then server-based text search, it's for exact matches only, consumes library server resources, and it is again limited to AFP and PDF. So the design goals for full text index were support complex queries, search optimal terms, fuzzy searches, and proximity searches, and it had weighted searches. It is used for highlighting a query score to improve the query score, and for cross-platform database, it has had to be database independent and for high performance. So a full text search involved a on-demand to FTS server to the index. So in the FTS server, it would have text extraction, language identification, tokenization, and language analysis. So the text extraction would happen, and then this is used for pre-processing, and then it would identify the language. So depending on that, it would create tokens for each that was extracted, and then it would be placed into unstructured information management architecture, which it runs on top of Watson. Now, Watson is used for business intelligence. It is used for analysis, mostly for business intelligence. Now it runs on top of that. So it uses documents to be grouped into collections, and it is formed into a collection. It can add, remove, or search. These are the different functionalities it can do. Now, the functions used are FTI_add function, FTI_release function. So this is for the assignment number 1, and this is the end of Advanced Database Systems.